question that says evaluate using the Moivre's theory here. So we know that for the Moivre's theory here, if you have a complex number that's written in polar form, like this here, then we raise it to the power n here. So this here is simply equal to r here to the power n. Let me just do this. Okay, so this here is simply equal to r to the power n and n multiplied by theta like this here. So now, let's start with the first one here, a here. We have 1 plus I root of 3 here and 4 like this here. We need to write this complex number that is inside the brackets here in polar form. So now, we know that a complex number in polar form is written like this here. So we need to get the value of r here and we need to get the value of theta here. So now, r here is simply equal to the square root of x squared plus y squared like this. Then theta simply equal to tan inverse of y over x like this. Okay, so now if we look at this complex number that we have inside the brackets here, you'll notice that our x here is 1, our y is the root of 3 here. So meaning that here r there will simply be equal to the root of 1 squared plus the root of, okay, so the root of 1 squared plus the root of 3 squared like this here. So here, this and this are going to cancel. We're going to remain with the square root of 1 plus 3, which is simply the square root of 4, which will give us 2 here. Okay, so then for theta here, we say y divided by 3 here. So we're simply going to say tan inverse of the root of 3 over 1 here. So basically here, we say tan inverse of root 3 here. So now, if we punch tan inverse of root 3 there, so here we're getting tan inverse of the root of 3, we're getting 60 degrees like this here. So now, we know that here we have we need to write this now in polar form here. So meaning that in polar form, we're simply going to have z equal to 2 here. Let me do this. Okay, so we have z here equal to 2. Then the angle theta that we have is 60 degrees here. So now, remember in our question, this is raised to the power 4. So if this is raised to the power 4 here, this will just be equal to 2 to the power 4. And we have 4 here multiplied by 60 like this. So therefore, we're simply going to have 2 to the power 4, we get 16 here. Then this here is going to give us 240 degrees like this. Okay, so now if we want to write that in rectangular form here, if we want to write this answer that we have in rectangular form in the form of z equal to x plus y like this here, we know that x here is simply equal to r cos theta and y simply equal to r sin theta like this here. So the value for r here is 16. Then cos 240. Then this side we have 16 sine 240 like this. So the value for x here, so we have 16 cos 240 will give us negative 8 here. So the value of x here, okay, so the value of 8 here we're getting negative 8 there. Then let's punch for this one as well. So we have 16 sine 240. So 16 sine 240, we're getting negative 13.9. So we have negative 13.9 like this. So therefore, we have I plus, or 1 plus I root 3 here to the power 4 is simply equal to negative 8 minus negative 13.9 I like this. Okay, let's look at the next question then. Good. So we apply the same principle on B here. So for B there, we have the root of 3 minus I to the power 5 here. So we change what we have here into polar form here. So meaning that we need to write it in this form here. So here we know that r here simply equal to x squared plus y squared like this. Then theta simply equal to tan inverse of y over x like this. So now here, the value for x in this case is the root of 3 here. So we have root 3 squared plus negative 1 squared here. So here we're going to have the root of 4 here. So we have the root of 3 plus 1, which is the root of 4, which will simply give us 2 here. Like that. So now tan inverse here. So the value for theta here simply be equal to tan inverse of negative 1 divided by the root of 3. So this will give us, let me just punch this on the calculator. Okay, so this is giving me negative 30 degrees like this. So now what this negative simply means here is that this angle that we have falls in the 4th quadrant. So if it falls in the 4th quadrant here, we can just simply add 360 degrees here. So if you add 360 degrees here, you're simply going to get 330 degrees there. Okay, so on the Argand diagram, this looks like this. Okay, let me just erase this. Okay, so we're saying on the Argand diagram, this looks like this. So it falls here. So our angle of reference starts from here all the way up to this edge here. So then the 30 degrees is this angle that we have inside here. But then the value for theta here, we measure it starting from this point here all the way up to this edge here. Okay, so now let's get to the desired answer there. Okay, so now if this is the case here, then what we're simply going to have there is z is equal to where this r here, we put 2 there. So we're going to have 2, and the angle that we have 330 degrees here. So now if we raise this to the power 5 here, we're simply going to have 2 to the power 5 and 5 multiplied by 330 here. So we know that 2 to the power 5, we get 32 here. Then when we multiply 330 by 5, we get 1650 like this. So now we can get the equivalent of this angle in a smaller version. So if we say we just stop subtracting 360 until we get the desired angle there. So meaning that here, let me just do this quickly. Okay, so this here is the same as 32 here, and we have 210 degrees like this here. So now, if we have got 210 degrees there, what we're simply going to do here is we need to express this now in rectangular form here. So we know that the rectangular form of a complex number is simply x plus y like this here, where we know that the value of x is simply equal to r cos theta, and the value of y here is simply equal to r sin theta like this here. So we have our radius there, or we have our radius now here to be 32, which is the modulus there to be 32 here. So 32 cos 210, even this side we have 32 sin 210 like this here. So then here, okay, so here we say 32 cos 210, we get negative 27. So we have negative 27.7 like this. Then this side here, 32 sin 210, we get negative 16 here, like this here. So now, therefore, this answer here, the root of 3 minus 1 to the power minus I rather to the power 5 is simply equal to negative 27.7 minus 16 I like this. Okay, so you can go ahead and solve this one here, the second one there, by using the same method that we use here.